Представляю вам модератора сегодняшней сессии.
I present Tamara Golovina. She's the moderator of today's colleagues. I am very happy to welcome you here. IT technologies in the geological industry. We have lots of presentations. Two of them will be remotely executed. And we have different representatives of different industries and branches of exploration. And before we proceed, I request the participants to be right in time and to respond to the question, what's going to happen in 10 years in geological exploration? What will disappear and what new technologies will emerge? And I believe it's going to be a very interesting topic, but at least let's start the ball rolling. The floor is going to Chitalin Andrei Fedorovich. He's the senior geologist of the Institutes of Geotechnologies. Good afternoon, dear colleagues. Here's my presentation is dedicated to the structural analysis during the exploration and assessment of deposits, fantasies and illusions. Where we get it, they are coming from our life. When we come across the discussion of certain projects and fantasy, we understand that elaboration and inventing of an existing structure similar to the structure of the known deposits and models and illusion, it is justified the increase of the assessments of the resources. And reality is something which is based on geological data. In many projects, sometimes the structural analysis wasn't done, but sometimes it was done with a very low quality. And I will give you three examples how structural analysis help to get rid of fantasies and illusions and to save the money of the stockholders. Here is the gold-bearing deposit in Siberia. We've been tasked to make the assessment, and here is a very anticlinal fault with the deposits of gold. This is similar to Bendigar deposit in Australia. We analyzed the methodology, and this is a deviation of conditions to maintain this very simple structure, and we thought it was not correct, and we decided to make the analysis. We conducted the analysis of the primary data, and in many cases this model does not match the structural elements both in the cross-section, and here is the photo of the structure with different elements which turned out to be more complicated. This is ore deposit, and it turned out that it had this kind of shape. And concerning the lithology, we made a conclusion that the interpretation done by our predecessor didn't match the actual data. That was a fantasy, and the resources which were assessed were partially illusionary, and as was seen here on this picture, there is only one well, a fairly complicated geological body, but this is a fantasy. As an outcome, we conducted the analysis of the distribution of gold, and we understood that it was a very vast approximation, and gold has a clear-cut stratigraphic image, and this is cleavage and cracks in the rock. That was the kind of picture. and gold travels from one place to another and is not related to anything. As a result, we created our own model and our description of structural mineralization. And because we didn't go into detailed field surveys, and so that kind of picture we have now. Now let's go to Kazakhstan and let's analyze the copper deposit. More than 1,000 expressions of copper. We conducted the targeting, and the structural control of mineralization was done, and it was very well studied. Here is the expression which was of an interest to the customer. They conducted additional exploration, and here is the map of predecessors where rich ore bodies were identified, but actually the assessment was negative. When we prepared the project for additional exploration, the outcome was different to carry out in line with lithological structure. So this is all bodies were newly depicted, and all bodies they disintegrated, and actually we studied all the materials, went to the field and how it was calculated, and the predecessor, they were right, and those who followed, they actually basically presented the incorrect data. And this is the zone of extension and very well correlates with the polarization at the pit. And the general conclusion was that the predecessors designed inadequate model, and the decision was taken to abandon this site because it was not profitable to develop it. There's a copper porphyry site at Chukotka. Here is the copper abnormality, and that was a copper porphyry deposit. This is a forecast on geochemistry, and the customer wanted to carry out the exploration works, and we proposed to go to the field to make mapping to find the best possible places for the wells. And there is a number of sulfides, veins and strikes, and also followed by abnormalities. We changed the geological model, and resources were reduced substantially, perhaps more than 10 times, and the customer decided to discontinue the works, and that was too much of a geological risks that this deposit is feasible from economic viewpoint. Now, structural analysis on the basis of Drajne in Yakutia deposit. This is the ownership of GV Gold. This is the vein gold deposit, and people from St. Petersburg and from Moscow were invited, and structural models were created. They differ from one another, but basically demonstrate peculiarities. In our company, we've been working for 6 years. We conduct the full set of geological survey. We calculate reserves and resources, and we also carried out the scientific survey and research, and that's what we have been doing. We assessed the brittling and situation. We studied the structure of stockworks to identify which were gold-bearing and which were not. We carried out the mapping of the pip. We analyzed the type of watering and studied the geology of the pit. And special attention was dedicated to the computer tomography, which makes it possible to study the core and to understand the content of gold and sulfides. And they are going to use this method only recently, and which help us to get better and more accurate results. We structured the framework of ore stockworks, and we identified the position of the gold channels and veins. We studied the structural position of gold-bearing structures and not gold-bearing structures, and we created this comprehensive model where every gold-bearing stockworks on the right on the top. This is a horizontal compression and extension, and here lies in the area of fault. And we did the drilling, and as far as extension and spacing, we got a more accurate data. It explains many peculiarities of the deposits and has a value from the viewpoint of forecast. You can proceed and continue to look for the ore bodies, and this model could be used for similar deposits and structures. And this is the final structure, fantasies and delusions. You don't have to develop any fantasies. You have to study, better study, and we have certain sayings of experts. Novel Light, famous expert, he said that geological specialists should know all models, but when you study this deposit, forget about models. And 200 years ago, another scientist said, do the mapping and you will understand everything. So scientific approach should be used, facts, correct facts, analysis, synthesis, to create a model and to check the model on the basis of new data. And the method of analogs should be properly used. First, you have to find analogs, then you have to find evidence and similarity, and of course, specialists should be involved, structural geology. We are not surprised that some other specialists are involved in these works. When the site is very simple, there's no problem. But when it is more complicated, you have to invite specific experts who've been having vast experience in this matter. And this is, of course, requires the comprehensive analysis, structural analysis, mineralogy, and analysis of biophysics. Then we get the best possible results, but with minimum fantasies. I believe everything will be fine. So in this case, we will avoid going into fantasies, and we'll be remaining in the reality. Thank you very much for your attention. Andrei Fedorovich, thank you very much. I believe the structural geology is going through the epoch of resurrection. And tell us, please, what's happening? What are we going to have in 10 years? What is developing now, computerization, will continue to develop. And I believe that the forecast on the basis of the machine learning will continue to exist. And the most important thing, however it goes to develop, we need to rely on the experts with vast knowledge. Thank you. Our next presenter is going to be done in a remote manner. Anthony Benham, Principal Exploration Geologist. The floor is yours.
Anthony. Exploration, and apologies that I cannot be there in person. I'm currently working in Kazakhstan. My topic is when weaker is better than stronger, the use of ionic leach geochemistry in exploration. So it's an unfortunate but well-known fact that exploration is becoming more expensive and the number of discoveries that are being found is declining in recent years. This is an older slide, but it indicates just that on the left-hand side. Also, the depth of discoveries is generally increasing as well. The slide on the right-hand side indicates that, generally speaking, discoveries are being made a lot deeper with more obvious deposits located at the surface already having been largely explored or identified in many jurisdictions. And this is leading to pressure in the exploration industry. Now, typically, geochemistry has been used to a lot in exploration to identify the location of buried deposits. However, its uses are generally more restricted to deposits that are perhaps relatively shallow depths. It's not particularly a great use for locating deposits that are at depth. So the diagram on the screen now shows an example of a typical alteration profile around a buried porphyry. And geochemistry can be very effective in identifying these features by looking at the ratio between different elements. Generally speaking, this is what happens in soil and rock geochemistry. You have a grid over an area where samples are at regular intervals. However, the problem, as I said already, is that locating very deep deposits is not particularly effective using standard geochemical exploration, particularly where deposits have been, mineralization at depth has been transported down slope, for example, or from rivers. And the chart on the left illustrates some commonly used solvents that are used to dissolve elements in soils, typically with the strongest, commonly which are acidic, at the bottom of the slide. So these include things like aqua regia and 4-acid, for example. The acids or the solvents dissolve what's called the endogenic components, in other words, the primary constituents of the soil, as well as the exogenic components, which are the elements often of interest, the sulfide minerals, for example. However, ionic leach works slightly differently in that it's more concerned with extracting stripping the ions out of the sample rather than breaking the bond within the actual elements themselves. And it utilizes the higher contrast of elements, much more important than actually measuring their concentration. And this is where I get the title for my presentation from, that because ionic uses weaker or less acidic solutions, that actually in this case, weaker is better and allows the lowest detection limit. So for geochemistry then, the diagram on the right indicates the principle of ionic leach geochemistry, that unbound ionic species migrate directly above the source of a concealed ore body, which are then gradually over time converted to compounds, and these may migrate elsewhere. So the ionic response itself is directly above the source of mineralization. So as I say, it measures the precursor ion species. It doesn't record elements that have combined into surface products. The procedure, it selectively dissolves metal ions that have been leached from the primary mineralization, which then migrate and then concentrate near the surface. An ionic leach is able to detect 61 different elements, plus different isotopes, detecting well below crustal level abundances and natural background levels, and it provides an excellent signal to noise ratio. The methodology of how the ions are transported from the ore body to surface actually not definitively known. What is known is that ions are transported upwards through a variety of actions, including convection and capillary action. But this only allows the ions to reach the water table. Once they reach the water table, they then, what appears to happen is that the ions travel directly to the surface, or as close to the surface as possible, using a type of quantum physics, which operates at a very, very small scale. The important thing to consider is that whilst the transport methods themselves might not necessarily be definitively known, the facts do bear this out, that it does actually happen by known discoveries that have been used, that have been detected using ionic leach. So this slide gives you an example of, on the left-hand side, it gives an example of a concealed ore body that is buried beneath till. And the till is represented by the blue circles, with the mineralized fragments represented by the red circles. And you will notice that actually in this example, there is a higher concentration of mineralized fragments away from the ore body that may happen in a till environment. And standard geochemistry would indicate a higher concentration of mineralization away from the primary ore body. However, as can be shown from the diagram, the concealed ore body is actually in an area where comparatively small amount of mineralization has been detected. But what is important to understand is that it's the fingerprint, or the ratio between the different elements that is the most important here, rather than the actual concentration of the elements. We're looking for the fingerprints of the ore systems themselves. An example of where this project has been used comes from Venezuela. This is an example of an epithermal gold project that was sampled using conventional geochemistry, as well as ionic geochemistry looking for gold. And if you look on the right-hand side of the screen, where the cross-section is, I hope you may be able to see that two trench samples have been taken at surface. One indicating a lower grade of gold, and one with a slightly higher grade of gold. Now, the important thing to note here is that the mineralization on the left is actually the location of what was found to be the main ore body itself. And the one on the right was the transported ore body. So what you can see from this chart here, which represents the work from the ionic leach campaign, that a coincident gold and silver response has indicated the location of the primary target, whereas the lower gold and weak silver signal indicates chemically dispersed or secondary gold mineralization. You can also see coincidental information about the subsurface geology by looking at the nickel concentrations as well, which indicate the location of geological contacts, in this case, mafic rocks. Another example to talk about how long the actual process of ion migration takes. Well, we know it happens within 200 to 300 years, but it does depend upon the depth and the water availability and temperature. An example of another area that has been studied comes from Indonesia, which undertook ionic sampling through thick deposits that were erupted from the Krakatoa volcano in 1883. And these were between 1 and 1.5 meters thick. And what happened here is that the ionic analysis was able to identify two vein sets, which were 150 meters apart from each other. And this was compared with a later exercise of hand augering to determine the location of these veins. And it was found that actually the ionic leach campaign was more effective, more than 90% effective, compared with the hand augering, which only was effective 7% of the time. The actual methodology for taking the samples is very simple. Effectively, as long as you maintain a constant depth, that's the most important thing, and to avoiding cross-contamination. So surface vegetation, roots and soil and rocks are taken out, and a sample is collected at a constant depth, normally between 10 and 25 centimeters. The sample, between 100 and 150 grams of the sample, is extracted and put into a Ziploc bag and then sent off immediately for analysis. No preparation is required. So there's no crushing or screening or anything like that is required. An example where SRK has undertaken this work is in Rwanda, where we were looking at pegmatites. And the diagram on the right-hand side is a cross-section of the area that we were looking at, where 3 pegmatite veins were known to occur. And you will hopefully see the blue dots represent the sample positions. And you can see that from the graph above, that the anomalies are directly above the pegmatite veins. So in summary, we can show from the work that we undertook in Rwanda that it worked very well in a deep cover situation. The cover there was more than 15 meters in places, and it identified strong anomalies over the pegmatites. However, orientation sampling is often strongly recommended prior to undertaking this as a regional campaign in order to understand the actual background values that you might expect. The costs are slightly higher than traditional geochemical sampling, but this is offset by the fact that no preparation is required, and this will enable you to collect more samples per day with a corresponding low shipping costs. And it represents a good way of identifying primary anomalies rather than secondary or transported anomalies. The map here it shows with the circles the location of projects that SRK Exploration has undertaken or is about to undertake, including in the UK, West Africa and Central Africa, and we are in negotiations with Kazakhstan at present. So I hope that this has been a useful piece of introductory information about the technique, if you haven't heard about it, and I would be happy to answer any questions that you may have. you can drop me an email and I'll be happy to respond. Thanks very much for your time.
Спасибо, спасибо, Энтони, за доклад.
Thank you, Anthony, for your presentation. Indeed, the sensitivity which laboratories gives us makes it possible to apply such high sensitivity method, and the thickness of the cover rock is not an obstacle for geochemistry. And Anthony sent us a response to his response about the future of geochemistry. I will quote what he says. He says that exploration will move forward in the next years, becoming more online, which will enable you to use portable tools and laboratories on site, on locations, and the quick decision can be taken and exchange information via internet. And he also says that powerful, sensitive geophysical methods will become more accessible, become more cheaper, and will become wider spread. What will remain is necessity for geologists to prove results of their guesses, and he believes that the technology of drilling may also become more accessible, because the only method to provide the definitive proof is to do the sampling from the. Am I right in presenting your point of view?
Yes, absolutely.
Спасибо
Yes,
большое. Да.
absolutely right. Thanks, Tamara, for bringing up my points. I'm pleased that we had time to mention them. I know that you share a lot of my views, which is encouraging, and I would be interested in hearing the opinions of our other panelists on these as well.
Спасибо, Энтони.
Thank you, Anthony. The next presenter in our agenda is Evgeny Yermolenko, General Director of the Geophysical Service Company, GM Service. You have the floor. Good afternoon. I would like to make a presentation on this company. I have been in this company for 11 years. The presentation will deal with a standalone silver and gold deposits, and their features are that balls are quite rich in terms of the gold grade, and it's easy to recover. The topicality of this research is that recently no large discoveries have been made, and subsoil users have to be content with the increasing their reserves via satellites of the existing deposits. And in my presentation, I would like to share with you methodology of making discoveries. My presentation is divided into 3 parts. In the first part, I will show you schematic geologic genetic model of the epithermal deposit. In the next part, I will speak about physical and geology model, and the result I will share with you our ideas about the strategy of exploration. So, presently, the schematic geological genetic model of the epithermal deposit looks as shown. It's necessary to have a source as a magmatic body, the source of the fluids of the acid, channel of the migration of fluid. At a certain distance from the source, it is necessary to have a block of hard rock so that the fluid should be crystallized in a narrow zone and not be dissipated among many pores. So in this block, the richest veins form. There are 2 types of veins: LS with low sulfidization and high sulfidization deposits, of course. In my presentation, I will speak about low sulfidation ores, and they are more rich in terms of the grade. So we have made some studies in the Kamchatka and the Okhotsk region sea, and over this years we have accumulated vast sea of information actually. And this slide gives you an idea about the geological structure of the most studied vein zone. Here you can see the key results of the study and the proofs and factual materials are provided in a series publication which we have been making from 2014. I won't dwell on it now. Generally, the materials studied relates to 5 fields, and we have extensive materials both in geophysics and geochemistry. So we have summarized this information, and we have drawn a physical and geological model of this deposit. The boundaries of the water controlling interface is the border of the interface between 2 blocks, having various different geological and electrical structure. So the gradient of geomagnetic response would be quite pronounced, and the blocks can have different density, and over the blocks there will be gradient of anomaly magnetic field. The cover rocks are presented by tuffs, and the conductors are tuffs and ash, and these lavas are isolators. The zone per se, the deposit zone per se, is associated with the quartz mineralization. Is characterized by the high electrical resistivity and low magnetic sensitivity. The deposit is characterized by a classic geochemical zonation. There are under the below the ore association above and above the body mineralization. That means that despite the fact that less epithermic deposits are very difficult to discover for geophysical methods, but when you apply a complex of methods and when you track the data of geochemistry, this task can be resolved. Let me come to the third point of my agenda: strategy of exploration. Exploration say the necessity to use geoelectric gravity prospecting. The strategy should be divided into 2 parts, 2 phases rather. The first phase is localization of targets. In this phase, it is useful, stand the reason to use UAV and field. The UAV devices are very wide developed, and you can, for over 1 month, you can cover, depending on your choice of the device, between 500 square kilometers up to 50,000 linear kilometers in 1 month. So the example of the operations done in Kamchatka this year, you see as a result of processing and interpretation of the data, we have managed to locate key blocks and the faults, and identify linear zones, and even make some develop some ideas about the continuations of veins. But it should be noted that magnetic prospecting and gamma prospecting are secondary in importance as compared to application of ground-based technologies like gravity, soil geochemistry. The first phase could be done at the step of 100 and 200 meters, and it is also necessary to conduct a series of individual profiles, basic like magnetotelluric zoning. The distance interval is between 100 and 200 meters. Let us look at some examples. In one of the examples, based on the data of gravity, we discovered that the group of epidermic discoveries are localized in the area of graben. The graben is filled with less solid rhyolites, and you can see it on this diagram. And in addition to that, since the interval here of the screening was 100 by 200 meters, we managed to discover gradient zones, and we also identified 2 industrially valuable veins which are being developed now. It should be noted such technologies as gravity prospecting can be done and soil geochemistry done in a single go. That saves you money and saves you time. This year we covered 1,000 square kilometers of study, and the pair study was made of a geologist and geophysicist who took samples. So there were a team of 2 people who covered 1,000 square kilometers. And we were managed to complete this study before the end of the season. It should be noticed that for low sulfidation deposits, use of geochemistry is a must. So looking at that, whether we can define if there is a all gold, only geochemistry can tell us.
Specifically here on the eastern part of the deposit, we see the following picture, and now it is explored and developed on the industrial scale. Of course, we don't have to forget that gravity and magnetotelluric approach doesn't give the clear picture of the whole pit. And actually, here is the picture. We managed to understand the structure of the graben. These are elements of the different types of rock and disease. And here we managed to identify the dislocations in this area. They are considered to be ore controlling faults. Here is the first stage. This is the second stage, exploration on focused areas. We could actually make this bridging more dense. In our opinion, the basic tool which could be used here on isothermal deposits, we need a number of profiles here. And here we use this on this area. And here is the results of 3D visualizations of these pits. And we thought that veins were positioned from north to south. However, we couldn't find the veins, but then we found out that this is the zone of isolator, and it was actually shifting 120 meters to the east. And the forecast actually was proven in 6 months. And here is the area of isolator. Here is the second portion of this vein. And we carried out this work through 35 days and prepared a report. And now this ore is being taken to the processing factory. Conclusions. So it looks like the following. We need to work in 2 stages. The first stage, localization of targets, UAV, magnetic gamma spectrometry, gravity plus soil geometry, 10 to 400 meter steps. And we could offer this job to structural geological specialists. And for geochemistry and together with the use of geological exploration, does not increase the price of the works substantially, but the results of geochemistry helps us to carry out this work. We use this to understand the general layout of the situation. And second stage, exploration on focused areas. And here we find the magnetotelluric approach, 50 meter step. So that's all. Thank you very much for your attention. And 2015, we managed to work with the prominent professor Jeffrey Hedenquist, and that was a very nice experience. What would you tell us about the future of geophysics? And I believe any win, it is the work of the team, the joint work of geochemists, geologists, and Actually, it's not only our achievements, but this is a teamwork, and the better is cooperation, the more reliable the results will be. Very tight cooperation of these engineers will lead us to success. Thank you very much. The next speaker, Sergey Turhanov, Geosolutions geologist. Good afternoon, colleagues. The topic of my presentation is the use of data of RC drilling when making assessment of ore deposits, and this reverse circulation drilling is vastly developing among the companies, and this is used for detailed exploration, and when making the assessment of resources, these data received with this type of drilling, these data is not used. Here are the general data on the volume of RC drilling in Russia and some other countries with developed mining industry. The share of RC drilling in Russia is not very high, whereas in other countries the data of RC and the volume exceeds the conventional types of drilling, and in some countries this is the basic method during the exploration. That is attractive because of high speed of drilling and cheaper costs. And the major difference, the drilling sludge is coming on the surface through the system of dual pipelines, and actually that contaminates the soil. It comes to the surface into the cyclone, and then it is processed in the cyclone, and the basic RC machines, they are equipped with the dividers so that the human factor is not influencing the whole process. However, we have certain errors during RC drilling, and one of the problems is the lack of adequate size of the sludge sample. And when automatic methods, we are losing small and large particles of the sample, and that distorts the final results from the same interval. And there are other factors which negatively is influencing the sludge sample. This is untimely cleaning of the equipment, and the basic reason or a problem of using RC wells is the complexity of mountain conditions, flooding of the mine working, and when we have flooding, so the sludge coming to the surface is wet, and it clings to the walls, and we contaminate the ordinary samples or regular samples. And here is the example of what is happening. And we see the comparisons of the content of the regular samples, and we can clearly see that where the grade is less than 0.3 grams per ton is smooth dynamics, and when we have more than 0.3 grams per ton, we find the discrepancy. We have chaotic results, and we cannot elaborate or tell what is good and what is not. Or we can witness certain kind of contamination when sampling this type of material. Well, there are also methods to somehow level the existing discrepancies. But that also could affect the time required to carry out the investigation or certain processes. And primarily, we have to carry out experimental efforts to consider the use of more effective equipment, but the quality will definitely be higher, and despite of the fact that we have a better system of sampling, but there might be certain errors, and the lack of control on behalf of geologists, not adequate cleaning or some other areas may end up in inaccurate results. We have to have continuity in carrying out exploration works. We need to ensure proper documentation of sludge. And finally, we have to create a general system which will help us to understand the source of errors which might occur, and also to develop the measures to get rid out of these drawbacks. And RC drilling will be useless if we don't have a system of quality sampling, and perhaps what needs to be done from the very beginning before we use the production or exploration works. RC drilling is considered to be less accurate of testing as compared with the diamond drilling. RC drilling contaminates large samples. There we have the abrasion as per the walls, and also certain distortions in terms of the cores, which is characterized at the stock works and at vein expressions that could lead to enrichment or depletion of the sample results. And evidence to that is the amount of sludge, which might rise to 50%. And in terms of conventional type of drilling, we have 100%. But still, we observe the abrasion of small particles which affect the final assessment. However, the conventional type of drilling is more accurate. However, the existing practice is based on comparison of the intervals, converged intervals. And there are several methods to justify that. First is the drilling of pads of core and IC drilling, drilling of the mountain works, channel sampling. Here, it is necessary to carry out testing very close to the well bore and to compare such adjacent parameters. And all methods of proving they're very well known. They are used during the conventional type of drilling, channel type of drilling, and the most common. We need also to take into account the peculiarities of the deposit and to choose the wells with minimum distance between them. Next, after receipt or after carrying out this proof works, we have to carry out a traditional analysis of data between the conventional and RC drillings and to find the discrepancies. The comparison should be carried out as per the grade of the components and linear resources. We also have to create separate sectors of detailing, and the accounting of resources should be done separately for conventional and RC drilling, and then to make this comparison. The materials should be also offered for consideration, and if the results of comparisons are satisfactory, they are allowed to use this methodology to carry out the assessment of the resources. And if we find certain errors in a systemic matter, there might be correcting coefficients, which is the responsibility of the Commission, and corrective coefficients could be also used for RC drilling. And first of all, you have to pay attention to the quality of the sludge material, for the risks are being borne by the subsoil user who is designing these models, and any types of testing should be related to the geological peculiarities of specific deposit. I'm through with my presentation. Thank you very much, Sergey. I have a question concerning the topic of the presentation. So did you have the experience of providing teokonditia? I didn't have this experience, and we offered the methodology of RC drilling for the state expertise, and two methodologies were approved and received a positive assessment. And while you observe recommendations you were talking about, so partially the conventional type of drilling could be replaced, provided the proven works are carried out. Thank you very much. So my traditional question, how do you see the future of geological exploration? I believe everything will remain at the same level, but I hope the quality will be improved of the geological surveys and the speed. The time will be lesser, and sometimes they ignore the quality in favor of time. And now, next speaker is Mr. Vasilyev, Mineral Exploration Network. Good afternoon, colleagues. I represent two companies, Mineral Exploration. This is a junior exploration company, and second company, Mefalab U. It's a Finnish service company which emerged from the previous company, which actually working in Spain and Finland.
The agenda of my presentation is as goes. I will very quickly cover some methodologies which were developed in the period of our prospecting activity, exploration activity, and I will dwell for a longer time on this Gerda complex used for geochemical studies. And we position it as an all-purpose platform for many other portable instruments which can be used and interchanged on a modular fashion. So I also cover the issue of integration of this system with new tools and with new technologies. Well, our company was registered in 2009. It's a UK company. The subsidiaries in Spain and Finland. We have two subsidiaries and the joint venture with the Polymetal. We also have a ongoing project in Chukotka. This is a classic junior business. We take large areas, we identify prospective sites, and we conduct a whole complex of studies on geochemical, and we verify targets by drilling verification boreholes to see if there is a mineralization in the core. The next phase, we invite partners. In Finland, we invited Kemiros, with Kinross. On Chukotka, Polymetal. The model of operation is suitable and good. We're satisfied. So this is the picture which we all like. The density of results in good results. So is isolated, say, points of sampling is not good enough, and this is something which we saw in Finland. It's easy to miss such a target in Finland, and we developed net grid with a density of 10 by 100. And we understood that it was necessary to process this data and to cover the areas. One of the examples, this is a project in Bagrasan. It's a large ore field. We have tungsten, oil, or gold. There are intrusions. The spot is city. Its scale is 1 kilometer, 20 by 20 kilometers. So we collected more than 800,000 geochemical samples using analytic classical methodology. It would cost us a pretty penny, which we would not be able to support as junior company in Finland. We understood that we need a certain cheap, accessible method of exploration of large areas, effective for a cheap rate. So we developed a method of MEFA. It competes with MMA. It's multi-element fraction analysis. The difference is that we take a smaller size of sample, which is important in Nordic conditions. In Lapland, in Chukotka, you do not need 100, only 30 or 50 grams of soil as a sample, not 100 to 100. So the first phase, all samples are processed via the X-ray fluorescent analysis in order to understand if there are any satellite elements. So we definitely will be looking for gold, but at the first phase, in order to enhance the density, we conduct all samples, the same date via the X-ray fluorescent machine, which is a mobile one. Next phase, we could conduct preparations. We reduce samples down to 5 to 6 grams, and then in a backpack you can take to the laboratory. We have a laboratory, the joint venture is located in St. Louis. The thin fraction is placed on a pallet. Well, I don't want to spend too much time on methodology. I invited to visit our booth, and we don't have any chemistry. There is no distortion of signal, and the fraction is analyzed by laser. So in terms of sensitivity, we are not less than as MMI, but in terms of contrast and verification, we are much better. We have conducted a lot of test metal work in a variety of locations, and the cases prove that the method works very well indeed. The laboratory located in St. Petersburg is available, and you're welcome to use it. So these are some of the results. This is the same area. We identified some areas in terms of arsenium, and we saw that the higher the content of arsenium, the target would contain tungsten, and these results have been verified by drilling already. When the arsenium content was lower, then the gold was found, and also some core drilling was conducted, and these results, these conclusions have been verified. So this raw ore assay field is well characterized. Definitely, we now have to go for more dense drilling, and this scope of samples is difficult to digest on one day. It is not possible, rather, to do it manually. That's why some automation would be required, and we understood that some analyzers would be necessary. We started with enough X alpha, then we use this delta, and now we use Olympus Vanta, and we sort of made friends with Olympus, and we understood that it was necessary to automate the process, and we have made this solution. We use the three-axis computer-driven, machine. We combine them together. We developed software using the Petrozavodsk University and launched this sort of instrument, if you will, into operation. So you see on this photograph soil samples without preparation. It's easy to use it for mapping. This machine can also be used to study core. It is easy to develop template. You see the computer on the background, and the template is generated. It is also possible to use you have micro camera, which enables us to make good pictures for mineralogical purposes, and we also conducted certain work relating to the detection of gold using RxEF based on the effect of native gold. So this picture shows you an idea where the native gold is seen, then found. It shows, and it works when you repeat study of the same sample on a number of times. So this is our methodological work. We want to use the sample with a thickness of 2 millimeters, and when the grain of gold was found, then we conducted the grid 20 by 20, 400 measurements. Then we change the grid 100, and this is the 400 is compared with the assay. But correlation is very great when we took 100 measurements, but the interval can be identified in order to decrease the number of samples to be sent to my laboratory, to the mainland, to speak in the interval should be identified in terms of gold. And when we saw that everything works fine, we decided to develop our own, create our own service company, and to provide service in terms of soil geochemistry, and we sell Gerda installations for clients. So this is a list of locations where our hardware and software operates. We provide technical support on a 25/7 basis via remote access right now. We have spectra scans made by Russian producers, X-ray analyzers, which operates very successfully on polymetal, and the Olympus Vanta operates very well. We also did some methodological work using magnetometry. Everything works perfectly. And we see now that other companies are evincing interest to us who offer portable instruments to market, and now we interact with their aspect. They opened to us access last year. We signed with the company Tracer an agreement. They open us their protocols, and we will expand the range of hardware which will be accessible on the platform of Gerda. And I would also like to mention something about the operative hyperspectral spectroscopy. The method has been verified. Now it's becoming more and more popular in Russia too, and the complex approach is good. Perhaps sometimes you may have to use certain specific methods like spectroscopy, especially in respect of copper and porphyry, targets where we have partners, and I invite you to approach us with it. One of the methods which presently is widely used by the Americans, for example, in one briefcase you have a portable PXRF and it's a laser-based spectrometry. A small part of a sample is burnt out and spectrometry is conducted in a Russian city of Novosibirsk. This solution was also made. In terms of technological integration, I would like to say the following. In continuation of the previous presentation of my colleague in terms of quality of sampling, I would like to say that we interact with our Finnish partners who produce automated sampler. They call it soft core. It looks like types of sausages which you see on the picture, and you can very quickly analyze it using the Gerda complex. They have very good results. They have conclusions of experts. You can control it remotely from the cabin. You can use up as many as 8 such samplers. You can regulate it from your cabin the rate of sample taken. You can change the mode. It's a rather convenient set of hardware and software. It's operated in Finland, and if say there is too much water, then the plastic is replaced with fabric bags. And another technological integration is shown on this slide. We agreed with our colleagues from AGR. We agreed that we will provide some additions, the enrichment to the Gerda, and we have already doing some templates in Chukotka for our project in Chukotka, where Gerda is used effectively. And the advantages, let me list my advantages as compared with Western analogs. I give you an idea. This installation is very complicated, but you see the quality of the core. The core is very great. All geologists said, no, it's not possible, so you have to take it from the, box. What you will do with this machine? Redundancy. So you have to, you won't be able to use all of this. And the cost, of course, of such installation costs 1.5 million, and our also costs 1.5 million rubles, not dollars, actually. So, and responding to the question was by the moderator, responding to that, as the previous speakers opined, and said that the accumulation of data and computerization will result in a qualitative jump in artificial intelligence will become the order of the day, and analytics will be more field-oriented and field-located, if you will. More mobile equipment would be used in the field, and it will the unmanned surface-driven drones will also be used, and will be using such self-driven say, unmanned vehicle, we should be able to conduct exploration. Obviously, it will not be able to navigate all the terrain, but in Kazakhstan and in Spain, where there is rough flat terrains, it will be very useful to use. Thank you, Igor, for your presentation. Let me tell you that Igor and his company is a good example of the cooperation with a variety of partners, and they are doing well. They are not afraid of innovation, and this is also, I think, the order of the day, and we should imitate their work and do the networking. Thank you. The next presenting is Rostislav Belik, General Director of RGR Software. Colleagues, good afternoon. Our company, so from 2009, for 11 years, have been doing something related to implementation of the digital documentations of mining in the area of mining. Over this period of time, we have learned to document digitally all types of boreholes, mines, and you can see the pictures, certain pictures from our sites, from projects where the AGR system is used. We have made some calculations and found out that in the format of AGR, more than 15 million meters of mining have been documented, and in the digital format, to understand why I focus your attention on this particular number. A few words about the software. Conceptually, it is installed either on a notebook or tablet. It's an instrument of the field geologist. It is a set of interconnected, pre-tuned tables so that field geologists can conduct interval-based geology. So a geologist has to go from one table to another and picking up values from specific drop-down menus to document a number of geological parameters. The key element here is that each geological parameter, as a result, is given representing 3D coordination, and this documentation, of course, is done at the level, depth of 100 meters, for example, and geologists feel that such rocks, such and such dissipation of fishes up to 100 parameters can be documented, and if you know the depth, the coordinate of the well mouth, and the software recalculates the exact parameters, and you get as an output the exact location of the target, and you can do the simulation. It's beyond our software, but you can micromine and some other systems. You will feed our data can be fed into those systems to do the modeling. There are a number of auxiliary elements like reporting, generating a full reports, set of reports, like columns, passports, logs, and acts of, so all the entire set of documents can be engineered. And it is also possible to have online monitoring of this process using the dashboard, how many meters of bore holes is bored. So these tools of digitalization, and all it works. It has been in operation for more than 10 years, and this is done in a very convenient way. So we, on the other hand, we decided to think what can be done to make the work of a geologist even more comfortable. And we found out that as of now, a geologist is equipped sufficiently well. Technically, we have has computers, good digital cameras. That's fine, but quite often the environment in which documentations are made are far from being convenient and comfortable in certain areas. So geologists have to operate in the open or in sheds using some makeshift tables. So we decided to develop in a very ergonomic way, a workstation for a geologist.
Вот в прошлом году мы привозили на MINEX сюда вот такие столы синенькие.
Last year, we brought to the MINEX the special tables, and that was the first generation for deploying the core samples. These are inclined board tables, and that was the first trial. And we have a subdivision which provides the services, and they used these tables, and within a year's times we redesigned these tables, and this is a higher degree of automation. And here at the bottom you can see the shelves where you can store the core from the well pad frozen. Here you could obtain normal temperature, and defreezing process is going on. What is placed on the rollers, the next portion of batch is defreezing, and the tables contain from these sections of different length, 2, 3 meters, meter and 80. You can assemble any length you desire to have, and the workers on the left part, they brought the box with a core, then you document it, and then you shift the boxes to the right, and you can see the photo camera there for taking picture. Further to the right, you can move it. If you need to cut the core, and even further to the adjacent premise, so that you continue the process, and you can use drop labs equipment, and you can continue this conveyor line further on. There is also a compressor with a feed of compressed air and the water feed pipeline. Here you might find the characteristics of these working table, and our booth is number 13, and the element of this kind of table is there, and the angle could change from 0 to 45 degrees, and actually we have very convenient tables for core analysis. This is the example. This is a Kuronak deposit, Polizolator company. That's the kind of a table they're using there. A little bit more about the digitalization of the core. I spoke about 15 million meters reflected in the data. Let's look at this a little in a greater detail. We have this amount of core, and this is the box with core. And this is the geological description. Behind every word, there is a code from database with 3 coordinates. We have a picture of the image and the digital signature. It is a predetermined data set. You can develop the neural network so that in the near future you could identify the type of core with the help of artificial intelligence. And actually the whole world is joining these tendencies. They are working in Australia in SRK, Digital Petroleum Company. This is a Russian company. And perhaps they have the maximum progress in this direction here in Russia. The average accuracy is 80–85% of recognizing, but not for all geological parameters, perhaps for 10 to 15. And manually, the geological specialist can do up to 100 parameters, and Perhaps this technology is in the beginning, and anticipating the question from Tamara Alexandrovna, in 10 years, perhaps this process is going to be automatically documented 100%, and that mission could be resolved, and from expert geological, it could be brought to a practical level. We clearly understand that technologies, they are developing very quickly, and in order to be a specialist in specific topic, you have to be involved for dozens of years, and we are deeply involved in e-documentation. We would like to augment our system with the use of artificial intelligence, and we will perhaps need another 10 years or some kind of tremendous resources. However, strategically, it is much more correct to join in cooperation and partnership. We work with Digital Petroleum company, and here the data is integrated into the web solutions from Digital Petroleum, and these algorithms could be used, and in future we will add the possibility for offline operation of the documentator. We also get integrated from the viewpoint of design and information in Gerda, which was prompted by our predecessor, and that could be installed for deploying the core samples. And we have also studied this and learned to make it in practice. It is important that on the girder you may install different types of equipment, high-resolution cameras, and you can create images not only of one box, but 20 photos of high resolution of many boxes, and we are going to have much more accurate initial information for further machine learning and artificial intelligence, and you can identify the samples almost up to 100%. And our proposal to all largest subsoil users, Nordnickel and Severstal, to make a step forward towards these experimental efforts. Of course, you won't receive immediate results to get those robotized features or gadgets to carry out documentation on that as far as or as deep as 3 to 4 kilometers of the core material, and that requires financial resources. I call upon all the colleagues not to be frightened with this, and technologically, and ourselves and our partners are prepared to get involved in these projects, and over the horizons of 5 years, the artificial intelligence will not be able to master all things. It's going to be simply a support in decision taking when we make photos, process, and provides certain preliminary data to the geological experts, which will help him to add something to the information he has. However, the general productivity may rise as much as 2 times, and after some more time, and algorithm will be further advanced, and in 10 years, I believe a fully automatic process of that kind, and the source of data will also be greater. And in 10 years, we put the box on this table, and this box moves by a server drive,
робот будет ставить.
or a robot will get involved, will feed to the system the box with a core, and at the output you'll get the geological database with partially processed information and certain recommendations. Of course, the geologist will remain, but he will be solving the missions of higher level. Thank you very much for your presentation, and I can't but touch upon the following, and the conditions of labor were also discussed here, and now geologist branch has to compete with other industries, and young people, they feel reluctant to be geologists. However, concerning the operations in the future, big companies are prepared to work, and consulting companies, but there is no leader who would take up and organize everything, because the organizational part here perhaps is even more important than that the investments is something of the second background. The next presentation, Alexander Prihodka, senior geophysicist. Good afternoon, dear friends, colleagues. Thanks to the organizers for giving the opportunity to speak in front of you, and to those who are watching this presentation. I'm going to talk about aero-electromagnetic technologies, Mobilim MT, and I will demonstrate practical use of these gadgets. I will start with the characteristics of the basic principles of aero-electromagnetic methods, and then how it is used, and on the field examples from different parts of the world. I will demonstrate how it works, and we'll talk about the band, about the components, conditions to work in difficult terrain under heavy interference. We have four basic principles, and they differ in terms of the sources of the feeding field and the depth of research. It depends on different parameters, and here we'll give you approximate assessments. Along with this, concerning the transient process, the fairly low resolution and the lack of its efficiency in different fields. And it also depends on the height of the flight. And this system is working in audio frequent band, and that ensures the maximum depth of the study, and at the same time has both good sensitivity to the conductors in the audio frequency band. Mobile T technologies, they are using natural fields of the Earth to study the geological environment. This activity on a planetary scale, inducing electrical current known as relic, and that creates electromagnetic source of signals which could be measured. And on the basis of the comparison of the data, we single out the signal of the field and the signal induced by the geological environment, and find the conductivity at different bands. And the accuracy actually is increased with the reduction of the frequency parameters. The basic technical parameters and the capabilities of the system are reflected in this table. The measurement of three components, variation of magnetic fields, ensures the sensitivity of the system, working in both horizontal and that ranges from 26 to, which ensures the receipt of geological information. And this frequency is split up to 3 windows, which defines very high resolution at the depth and high frequency of digitalization, electric components on the base stations. They reduce the noise of interference. Now let's pass over to the examples. This is the data as compared with the previous system, which is also based on natural fields, which was designed 15 years ago, which measures only one vertical components, only on 5 or 4 frequencies. We definitely see here higher resolution, and then because of the lack of the horizontal components, it doesn't find the contacts with the foundation, and sub-horizontal conductors, they are making errors. And mobile MT data on high frequencies, there are less contrast to the resistance. This part of the pit is demonstrated on the previous, matches the on-ground sensing, and the results are very similar to each other. And this is the uranium deposits with their upper level about 800 meters, and a crystalline foundation. So the depth of research of mobile MT is depicted here. For example, on the left, in low resistance or low resistance of 100 meters and lower, the depth rate is amounting to 800 meters. This is the depth structure in Central Asia and Kyrgyzia, and from the viewpoint of exploration geology, it is very important to see as deep as possible. On the right, the depth of research is 2.5 kilometers, and here we can see the cupolar structure in the depth. And another example of mapping in the British Columbia, Canada, the gold is represented here. This is the actually cross-section of the specific resistance, which depicts this structure in area. On the maps, we can see the lines across which this cross-section is presented. And this is the example of mapping of the difference in the resistance. The top graph, this aerial system, which is measuring only a fair limited amount of data. And mobile MT is capable to go as deep as 1,500 meters.
This sample also gives an idea about high sensitivity of the resolution of our team-to-team technology in the high resistivity area, which is beyond the sensitivity of other electromagnetic method of transitory processes. in air electromagnetic methods with the artificial agitation of the field. The critical importance is the high latitude of the device. Then the depth of the penetrating field is drops very sharply, and it is very topical in mountainous areas when with a mobile RMT. The fact that the natural electromagnetic is beyond the surface of Earth, this system is very little dependent on the This is the sample of the Colorado state with the highly diversified profile where the module is the altitude is about 300 meters, but we do not see any differences on the changing altitude of the flight depending on the maps. This slide shows the result of the operations technology in the area of the industrial interference. Industrial interference do create issues, and quite often, sometimes it is simply impossible to obtain good data, but in many cases it is possible to retrieve useful information. This is known ore mineral at the east of Russia with the huge deposits of silver. Controlled by this upward structure, and the adjoining dome structure has great potential for new discoveries. Thus, air electromagnetic technology of mobile MTS based on natural electromagnetic fields has depth of study exceeding any other methods of aeromagnetic methods based on artificial agitation of the field, the sensitivity of irregularity in the upper and lower sections, and the sensitivity to the differentiation of the change of resistivity, and also using geoelectrical boundaries in any direction. I thank you for your patient hearing. I will be pleased to take your questions and to give my answers. You can send your questions to our email, which is shown on this slide. Thank you, Alexander. Can we ask you a question? Can you hear us? Well, please share with us your opinion about the future of geo exploration. If you can share with us another minute, it would be great if you articulate. Thank you. I thank you all for the attentive listening to my presentation. I believe that presently changes are already taking place. Great changes are taking place, and we see it using even today's presentations. And the industry historically is a transitory stage from transition from the surface methods of study to subsurface methods. And sometimes in the future you will see very few indications on the surface. And this factor will influence greatly all aspects of the industry, and geophysicists will play an increasing role as occurred in the oil and gas industry about 100 years ago. But in our industry of rock minerals and applied geophysics, there are certain specific features, and we are in a more complicated situation which would require development in parallel and systematization of geological knowledge, development of exploration models from regional to local scales, application of modern computing methods, and new methods like global basis, neural networks, machine learning. They will become most probably the foundation of the deepening of the knowledge which we obtain in our work. And your question, so whether geophysics will help us to discover large deposits, well, it's a utopical question, and it may be applicable to high contrast targets only, as this direction, but generally I would like the geophysics by itself is helpless. Thank you. It's difficult not to subscribe to this opinion. And we have the last presentation in this section, Alexey Trusov, head of the Department of Geophysical Technologies of Aerophysics, GNPP. Good afternoon, colleagues. My presentation will deal with the new air electro exploration system Horizon. At the beginning, I would like to say that generally in our company, Geophysics, we have accumulated a vast experience of application of foreign impulse pulse systems, starting from year 2004. We have been using the systems, AeroTeam and VTEM, in a variety of regions of Russia, and correspondingly, we have gained vast experience in operations, and we know the specific applicability of their use for a variety of purposes, of tasks, and addressing a variety of tasks. And by summarizing this experience, together with our colleagues from Canada and China, we developed in the year 2019 the system which we baptized Horizon, and we started to test it. We started test flights. We flew it in the Archangel regions where we have some materials obtained from other systems in the northern western region. We conducted flights with frequency systems, and recently we did some data collection using TeleTem. So the key parameters of the system of Horizon are shown on this slide. It is different in that it allows to fine-tune on key parameters, basic frequency, duration of pulse, and dipole moments, and the shape of a pulse. That means that before you start actually the data collection, the studies, we start our operation by modeling. We try to assess those parameters which we should feed into the system to address a specific task facing us. So one of the key trends recently in terms of pulse system was a decrease of base frequency. If all systems worldwide are currently use the frequency 25 Hertz, recently, well, the trend is to reduce the frequency down to 12.13 or 12.5 Hertz. So, give you an example of comparison of data collection in the Archangel region. This is a quite known kimberlite pipe, and the upper cross-section, is based using data obtained by the Horizon system, and the lower section cross-section is made using the data obtained from ELITEM. And you can see that the degree of detail are comparable, and in a certain sense, Horizon even better than the Western system. On top of that, we in the company continue to develop frequency-based systems. 2 years ago, we launched the project on suspension system, well, the so-called deep system EM48, which was fixed around the body of the helicopter or, say, aircraft. But now this feature has been removed. It can be towed on a rope, rather. using the helicopter, which allows us to expand the range of, say, aircraft or helicopters used for such data collection. If we compare the frequency-based and pulse-based system, we can see that frequency-based system allows us a wider range of registration of resistivity, higher sensitivity. The materials gives us a chance to dissect the cross-section into various sections depending on the resistivity. So the future, I think, is with the pulse system. They can penetrate to greater depths, and they can provide higher details in terms of the cross-section depth-wise. Here on this slide you see our approaches relating to interpretation of the data collected. Interpretation starts from the building up of geoelectrical sections. We use for this purpose algorithm one dimension inversion with the spatial regularization. And once these models are no good, then for certain anomalies we use object simulation. We approximate certain anomalies by a set of conductive planes, and we assess their parameters based on the depth, slope, and angle of inclination. Here you see certain examples of our work done. This is one of the key objective is to check the mapping of the mineralization areas. We see how in the data of electrical exploration rift-gene depressions are shown, which are filled with loose rock and which show low resistivity. It's also possible to map using this method tectonic structures, faults, ruptures, and implicative structures in certain cases can be easily mapped when there is some kind of interlaying of conductive rocks like contacting carbon, and they can also be seen in the materials of electrical exploration. On top of that, intrusive complexes can also be identified with a high degree of definition, and the volcanic complexes, they show different, but they can be identified and detected with a high degree of probability, or certainty rather. And what is greatly important is that we can see a variety of overlaying processes, like weakened zones of crushing, fissures, which are shown together with conductive zones, and also zones of end contacts with a variety of intrusive objects. In terms of results of simulations, I would like to say we build up 3D models. Here's certain samples of such models of magnetic sensitivity of the objects which are highlighted by using the data of electric explorations for conductive object located in the Urals area, and correspondingly there is great opportunities to visualize those models in terms of presenting them in vertical sections, and this 3D model of resistivity can be analyzed in a variety of ways. One of our latest projects completed only last month in September in the Baikal region resulted in the pictures shown here. You can easily see on this map conductive zones. You see dissipation of zones of conductivity with a variety of, say, delays, and cross sections will be built using this data, and geological interpretation of this material will be done. So, summing up, I would like to say that the system, Horizon system, makes it possible to address a wide range of prospective tasks, in particular, purposeful prospecting for sulfide, copper and nickel deposits and polymetallic, or it can be also used to address engineering and geological tasks like assessment of the spatial dissipation of aquifer formations, zones of permafrost, and it's possible also to detect prospective zones. By and large, I would like to say that application of electrical methods of exploration makes it possible to substantially increase the volume of geological data, especially in respect of low contrast objects, and the reason for using this, the justification for using this system, Horizon is that it is possible to fine-tune parameters to address specific tasks based on the features of specific geological formation. I would also like to highlight the following thing. In this season, we concluded our testing program using a new area-based gravimeter, enabling us to include, it's a new type of an instrument, and which could be included into the whole set of equipment. So such studies can be done concurrently with aero gamma spectrum, aero exploration, gravitometry. One, aircraft, one helicopter carried a full set of instruments. So this data now being processed, and I think we'll be in a position to make a presentation about the results of this campaign. Thank you very much for your patient hearing. Alexei, you've done a great job. Thank you very much indeed. And what is your opinion about the development of geology exploration in the next 10 years? I believe that development will be connected gently with the development of geophysical methods, and in this respect, land-based and aerial methods are already on the verge of crossing the threshold. We can see development across all directions. I believe that modern technologies, including aero-based electrical explorations, are developed well enough, and they will be helpful in addressing the majority of tasks facing us today and which we'll face tomorrow. Thank you for your opinion. Colleagues, we have 2 minutes. If somebody wants to stand up and ask a question to the speakers, you have this chance. Well, unfortunately, the interpreter cannot hear. Okay, I would like to know more about the system, about the quality of data collection. Understand that those bags are charged, and how they are purged, with what periodicity. Переводчики вас не слышат, микрофон говорите обязательно. Да, выйди на трибуну, вас услышно будет там. Okay, thank you. The sampling, the machine for sampling. Well, we have a large publication written by a Finnish expert who studied the representatives of this hardware for sampling, and he compared a variety of models. I would be pleased to share with you this article. You'll be able to get it. You will have plenty of information. and one should not have any doubt about the representative of the data collected. So as for servicing, definitely the high water content sometimes occurs, and this is an issue, but this can be addressed by use not of plastic bags, but fabric bags. You can see them on our booth, and this idea of soft core is realized in our sampling machine, and those fabric-based bags well, can sit for 10-15 minutes, the water drips down, drains down, and the apparatus itself can be opened quite easily. The cover is open and you can clean it and purge it. It's very easy to service. You don't need to, and the operation is done from the booth of the operator of the drilling department, and he can use the packages using the revolver-based mechanism and change the method of sampling. So it's easy, the three button to press. I invite you to visit our booth and you'll be able to see. Okay, colleagues, I invite you to wind up our section. Let me summarize what has been said today about the future, because I think it's a very topical issue, and together we form a certain vision which may be implemented, and the future depends on us. And I will agree with our colleagues that we are moving towards greater depth of exploration, search for discoveries at the greater depth. There's geochemistry with more sensitive would be applied, and I believe that geologic structures analysis is a classical approach which is now being revived, and we now see new methods. We now see more instruments for processing data, like tomography. It will be called upon, and many routine operations will be gradually replaced with automations, with artificial intelligence, and this connection requirements and expectation in respect of experts who would be using, servicing, and tuning and processing the data from these systems are very high indeed. And where are those experts? How we will train them? Who will train them? This is one of the something which we have on our agenda, and I think this may become the obstacle on the way of our technological process. We have a very great variety of opportunities and technological opportunities now trying to say impress us. People are not prepared quite sometimes, and companies are not ready to use such technology. So this is an issue. This is an issue. Perhaps this is a challenge, and which we are facing today. And this is the issue of cooperation and working as a team, multidisciplinary team. Sounds like a bad bundle, but it's not easy to get together people from a variety of companies, and you have to spend time who is the boss in the team, who will get what, and the trust toward each other, respect of innovations, and new development is something which requires additional effort, additional discussion. Experience, perhaps one should work, and it comes by itself. Thank you very much. I thank all participants and the speakers. See you out there in the fields, or maybe on the wings of the forum. Thank you.